Hello guys, my name is Yakov Fain. I'm a Java developer for 17 years, and I've been doing web development as well with different frameworks, and I didn't like any of them so far. So this is the first one I like, really. No, this is not true. We've been doing a lot of development with Adobe Flex. After Adobe abandoned this framework, they abandoned the framework. We still have a product, but it's like we've been in the future, and now we are back in JavaScript. And finally, we see the light at the end of the tunnel, because we are a company that creates products. We are a consulting company, and also we create products. And we cannot just play around and say, all right, let's do JavaScript because Flash Player is out. We carefully, very carefully assess, and it seems that Angular 2 and what's also important, today they released the first alpha of material design. So you can build UI components. So hopefully by the summer it'll be done. But Angular 2 is definitely the framework that we are switching to finally from Flex. So what is Angular 2? It's not AngularJS. That's first thing to note. The framework is component-based. No controllers, no scope, no digest, no apply, nothing to call. Very clean design, and it's a component-based. What else is important? It's very well performed. There is a site that compares performance of multiple frameworks. And this one, for example, regular Angular. Not bad, but you can see the changes, and underneath, on the right corner, you see the frames. Right now, it's at 40 frames per second, which is not bad at all. Not bad at all. But there is Angular number 2. Angular number 2, I'll show just one. Angular 2, this one, this web workers. If you can see down there, it's 120 frames per second. They split the rendering engine from the core Angular, so they can run the calculations in one thread and the rendering in the other thread. Besides that, the fact that they split rendering into separate layers, they can render templates which are not only HTML, but any other templating engine. In particular, during the last year, they are working with a company called Telerik, and they have native script, so you will be able, actually there are already a demo, you will be able to create mobile application with native UI. So you will have your Angular code, but the template part will be not HTML, but native script. Different render. More flexible DI, dependency injection. You're not injecting strings, you're injecting types. You don't need to worry about where to inject. There's only one place to inject. It's a constructor of a class. Also, reactive extensions. Even though it's a Google framework, but they collaborate with Microsoft pretty heavily. And the results are really good. Down, you can see reactive extension, RxJS, originated in Microsoft. Angular 2, the language actually for Angular 2 is recommended. TypeScript is recommended language. TypeScript is created at Microsoft by the same guy who created C# and Delphi. Now Microsoft is working specifically for Angular to parse the keywords and the content of templates. So you will have better type ahead help. So collaboration is great. So you can develop Angular 2 applications in TypeScript, which is preferred way, in Dart, in ECMAScript 6, in ECMAScript 5. We develop in TypeScript, and we like it. So in this presentation, I'm showing you only the code in TypeScript. First and foremost, it's a component-based framework. What does it mean? It means that your application is a collection of components. What is a component? Component is a class. Classes are supported in ECMAScript 6. and of course in TypeScript. TypeScript is a superset of JavaScript. A class is a syntax sugar. It's still JavaScript. It's still prototypal inheritance, but you write a class. You can say class A extends class B. The code is much easier to read. Take a look at this example up on top. You have a class and you have something above the class. This something, if you are a Java developer or maybe C# developer, it's very familiar to you. It's an annotation. So if you just write a class, it's a service. There is no special way to say this is my service. Something that you used to put in controllers is just a class. If you will annotate a class with an annotation component, at component, it becomes a component with rendering part. What is that part? Component and something inside. It's a metadata about your class. So if you program your business logic in the class, then you say, no echo. Then you say, it's not just a class. It has some metadata. I actually want to add some templating to this class. I want to add CSS. I want to say how I'm going to inject things. So it's kind of decoration. In TypeScript, they also use the word decorator. We used to use the word annotation. For us, it's annotation, so it is annotation. Now, a component, besides having this template part, it can have input and output. A component is a black box with two doors, or actually, no, two types of doors. You can have several doors, so the data come in to the component, which are input properties of the class. You mark them in a special way, I'll show you. Or a component can send data to the outside world through the output property. So a black box with inputs and output. Also, you can use lifecycle hooks. A component goes through stages. It gets created. The UI is initialized. You may change something, so change detection will work. And they provide you with methods, with hooks. So you can write a function. If you name it certain way, it'll be executed. It will be invoked. It's a callback at a certain time of the component lifecycle. So if you want to intercept it and do something about it, you can do that. Let's take a look at this screen. It's an application. It's the front end of the application. We developed this application. It's an online auction. It's a sample application. So what do we see here? It's a bunch of components. When you design your UI, you look at the screen and see, oh, navbar, it's a component. Down there, footer, it's a component. When I say component, think a class annotated with template and something else. On the left, you see a search box. It's a search component. In the middle, I see carousel. This one is actually from Twitter Bootstrap framework, a slider. It's a component. Down there, you see three products, featured products. Product is a component. And in a loop, you can say, I want to display so many components. Routing. Component routing works just great. So when you design a UI, you say, these parts of the single page application will stay all the time on the screen. But this area, which is called router outlet, is something where I will be switching and showing different components. So this area right there, as you can see it over here. And in this area, I can show home component, and then product detail component, and then about component, and then something else. But the application stays the same. On the right-hand side, you see a template, HTML. What do you see there? You see tags, custom tags. Every tag has a class behind it. So you write a class, and in the component section, you say selector. And this is the name of a tag that you can put on the UI, on the screen. So in this case, you can clearly see that I have auction navbar component on top. then a couple of divs, and then auction search, which is on the left, and then router outlet, and somewhere down the, actually, yeah, and at the bottom you see a footer. If you know, if anybody knows Bootstrap, probably you know, they have this flexible grid system, 12 grids. Over here, I'm using Bootstrap for styling, so I see, as you can see over here, 3 columns of this grid I give to the left part on the medium device and 9 columns to the rest. So this is HTML. And where is the code? The code is right there. Down there you can see, if you look at the very last line on this slide, you can see a class word. Class, export default class, application component, curly braces. There is nothing in that class in particular at this point. What else do you see? You see 2 annotations in the middle with a red arrow. You see component annotation. This is a metadata about this class. What do we see there? We see the word selector. What is the name you should use in the HTML page? In this case, I said I'm using auction application. So in the HTML, in angled brackets, you can put auction application. A little bit below, template URL. In this case, I decided to keep HTML separately in an HTML file. So I say, what is the URL of that file that I want to render? I could have put it right here inside, but in that case, it wouldn't be template URL, it would be template. What else do I see there? Directives. I list all other components that I need on this page, in particular, router, outlet, navbar, footer, search, home. A little over, router configuration. It's a component, it can have routes. You can do client-side navigation using the route config. What do you say there? You specify the fragment, the URL fragment, and we see if the path is / then in the middle, component to render, and to the right, the name of the route, alias technically. A little lower, path is, if the path has a fragment product, product ID, it means show this product detail component, render. But the name of this route is product detail. Simple. And where it's going to be shown in this area, in the router outlet, one or the other. The slides I don't, actually probably yes. If I can hit play, 1 second. That case mouse won't work, but that's okay. At least you can see it. Component router. By the way, if a component has a child component can declare its own routes. So it's not like router on the very top and you define the whole application there. No. Right in the component you say who are your kids, children. So what are the main building blocks for the router? Route config. This is where you define the routing, path, and navigation name. Router link. Obviously, you need to say, I want to display product detail or something else. So a anchor tag, but in the anchor tag, instead of saying href, you're saying router link, and you provide the name of the route. In this case, in this little example, you see a router link home and product detail. And when you want to display product detail, apparently you want to pass some ID of the product, right? In this sample, I pass 1, 2, 3, 4. So not only it's going to open the new route product detail view, but it'll pass 1, 2, 3, 4 as the ID for the product to this thing. Router outlet is a place where to render. You decide on your page where to put it. Route params. If we are passing 1, 2, 3, 4 to product detail, in the constructor of that product detail class, it'll use this special argument type, route params, and you will say this product ID equal params, for example, get ID. Or you can have multiple arguments there. Route data is a special case, not often you would use it. During the route config, you can specify some static piece of data that you want to pass in general. Maybe it's a development environment or production environment, something like this. Let's look at the home component. Home component, in turn, may have its own children, right? So import statement up on top. ECMAScript 6 introduced modules. So we are specifying, if I need something, I say import statement. Import from where? Either from Angular, if you use their features, or they could be your classes, your scripts that you wrote. If you want to be able to import a module from a different directory, for example, that module, that class, or maybe a function should be exported. So if you look down below, exporting a module. If I declare a class home component and I put export right there, why? Probably somebody else wants to import it, right? So it's probably using the root page. That class, what do we see in that class? That class has a variable products actually, it's array of type product. So array of type product, and what else we see there? We see a constructor of the class. By the way, this is syntax of ECMAScript 6 plus types. ECMAScript 6 has no types. TypeScript has types. Down there where dependency injection happening, you see that I declare the variable product service, private product service of type product service. TypeScript is a language with optional types. You don't have to. If you hate types, you can keep doing this for a couple of months until you understand that it's difficult to program without types because tooling won't help you. With types, tooling will help you a lot. Productivity-wise, it's much better to use types. So in this case, we declare a variable product service of type product service, capital P. Just the fact that we put it in the constructor means that it will be injected. That's it. No special syntax to specify. Whatever you declare as arguments of the constructors, whatever types you do, will be injected. The question is how Angular knows how to create an instance of this product service. And I'll tell you in a couple of slides. Binding. Everybody loves two-way binding in AngularJS, right? So they said it's not good anymore because it hurts performance. They didn't get rid of it, but by default, it's not the way the framework works. The framework works using so-called unidirectional binding. So everything originates from component, and like in this case, on top, you see header h1, hello, and double curlies. We are binding into template. So that expression will be evaluated. What is name? Name is a property of the class. There is a variable in class that you declared called name. So the value will be there. Could be any expression. The next line, span hidden in bracket. Is zip code valid? What does it mean? It means also binding, but binding of the property. Property of the, we are binding to the hidden property, the value declared in my class. In my class, I declare the value is zip code valid. So it's automatically, if it's false, it's a Boolean variable, then hidden is false, and you will see their message zip code is not valid. If it's true, you won't see this message. So binding from component property to the UI, to the template. How do you process events? How do you bind events to functions? Parentheses. That's it. All standard events that exist in DOM, just put it in parentheses. If tomorrow they will come up with a new event, just put it in parentheses. You don't need to do any prefixes to the standard DOM events. Click event, parentheses. We call the function place bid, or input field, the last line, input in parentheses. We call the handler for the event. Two-way binding. AngularJS developer said we want our two-way binding anyway. So they say if square brackets is for binding from properties to the UI, and parens are for binding from the UI back to the function, let's put them together. And this is basically a two-way binding. You put in there Angular's directive ng model, and that's it. So in this case, my component property is a variable. It's a class variable that you declared. Either you type in something in the input field and it automatically updates the variable, or you change the variable programmatically, it updates the UI. So to make sure that people are not confusing what to put where, first parens and then brackets are all the way around. Somebody thought of this banana box. Imagine two bananas, these are parentheses, right? So Ben Nadel created this nice diagram, or another diagram, the image, so you will remember this. Dependency injection is really, really powerful and more simple than in AngularJS. First of all, no strings, you're injecting types. Somebody has to create an instance of an object, an instance of a class. Maybe you want to inject a variable. Maybe you want to use a factory to create, like a factory functions. All this is possible, and it's a lot easier than it used to be. There are two major things to remember. There are providers, which is nothing like complicated like it used to be. It's a property, providers. You need to say how Angular is supposed to create an instance for you. So providers is where you say how to create an instance. But it's actually not an injection yet. If somebody will put an argument of, say, product service type in the constructor, declare it, then Angular will see, ooh, they want me to inject this product service. How am I supposed to create it? Did you define a provider in this component? Oh, no. So what do? Let me check the parent. Maybe define it there. No? Let me check the parent. So dependency injection, injectors exist for every component. Injectors creates a hierarchy of components. Providers are needed to tell injectors how. Accordingly, providers also have a hierarchy. So Angular will go through the chain up from your component if provider is not found. Moreover, you can create a provider on the root level. So you want to inject always this product service. And somewhere down the road, you can say, I want to do a mock service, mock product service. That one is not ready yet. So you just declare a line provider, and actually no, there's a line provide function, and in parentheses product service type now should be using mock product service type class. That's it. So provider on the components level will override whatever you declared up above. Let's look at the service, something that you would write in controller. There's no special keywords or anything, just write a class. In this case, it's product service class that has a method getProduct. In this case, it returns hard-coded values, but of course, you could have used HTTP and get it somewhere. But the point is, getProduct is a function. It's a syntax of TypeScript. You write a function name and then the type. It returns product type. The product type defined down below. How do you define classes? A class, properties, constructors, and the short syntax over here. Look at this. In the constructor, just by the fact that I put the word public, data access level, I could have used public or private. Because of that, during transpiling from TypeScript to JavaScript, automatically it'll create properties such as, in this case, ID, title, price, description on the object level. You don't need to write a constructor with a bunch of arguments and then write inside this.id equal ID, this.type equal something. So you don't need to do this. Sorry. Next. How do you inject? How do you inject? This is a class that has everything. It has a provider and it has an injector. So injection is happening in the constructor, only there. So when Angular sees this constructor here, I need to find how to inject product service. And a little right in the middle, you see a section in the component called providers. The short syntax that you see over here means just create a new instance of this class, of product service. There is a longer syntax, which means write a function provide. First argument, what do you want to create? Product service in this case. And second, how? You can write a function, you can write a factory in there if you want, and you can replace this one type with the other. So product service is a generic type. You can create an abstract class in TypeScript, and you can say my class implements product service. You can have real product service class, implements product service. You can have mock product service class, implements product service. So product service in this case is become a token, a name. It could be any name you want. But to that name, you can say, this name actually should be represented by mock product service or by real product service. All this is possible. So in this case, I have everything I need inside the component. Injector knows what is a provider. Up on top in the template, by the way, backticks note that the template code is taken not in single quotes, but backticks. When you use backticks, you can use multiple lines for HTML. Nice and clean to read HTML. How about in dependencies of dependencies? Let's look at this diagram from the left. We have a product component, and we want to inject product service in it. But product service needs HTTP, because it's going to go and grab some data from the server. HTTP is also a module, separate module in Angular, and you want it to be injected into product service, right? So dependency of product service is HTTP. Apparently, as you see down there in the code, class product service has a constructor which defines a variable HTTP, and that's it. That's an injection. So in product components, we'll be getting its product service. Angular will check, oh, product service needs HTTP, so it'll inject it there. No special coding is required. Looping. What used to be ng repeat. ng4, very simple. Let's look at this code from bottom up. You have a class, home component, with array products. You have a constructor. In that constructor, we inject the product service, and immediately we call the method getProduct. You can do it in constructor. In some cases, you need to put it in a different method. But the point is, when the products are returned, the member variable products, which is an array, will get some data. If you will look at this loop, ng4 with a star, what do we say there? Pound product of products. We are saying loop through that array. I don't know how many elements are there, but for every element, it will render this div that you see over there. Wherever you put ng4, that piece will be rendered as many times as need be. What do we have in that div? Oh, we have something called auction product item. So what do we understand? That somewhere there's a class with a metadata which has selector auction product item. How do you pass data to a component, and how do you get data from a component? You want to do it in a loosely coupled fashion. A component A shouldn't know about the environment anything. If a component A needs some data, somebody will give the data through the property which you will mark with annotation input. If a component did some calculations and it needs to report the results, a component shouldn't know who is my daddy or who will be getting the data from me. I calculated, I received the stock quote from the stock exchange. I shoot it out. I emit an event through the output property. If you are planning to send out the data, the results of your processing, you declare a variable or more and annotate it with output. And event emitter will send it out. To whom? I don't know. Whoever wants to listen, let them listen. They will be receiving custom event, which I will emit. So here's an example. I have a, look at this green line in the middle, order processor. Just by looking at this, I can guess, even though I wrote it, I can guess that apparently there is a component called order processor. What do I see? What are these brackets? Stock symbol. Apparently, there is inside of that component, there is an input property. So I am binding the variable stock that is defined down there inside the class app component. Just by putting stock symbol in the brackets, Angular understands that I want to pass the value of stock through the input parameter stock symbol to that child component. Now, if the user is entering on the screen here, they want to find the quote for some stock, for example. For example, they are entering ANTL or AAPL, and on change event, take a look, we put it in parentheses. We called on input event, and on input event supposed to get an event object, $event. But what am I getting in the on input event? I'm getting something called target. What is a target? It's one of the property on the event object, right? ECMAScript 6 introduced a feature called destructuring. Destructuring. So if you have an object with 10 properties, for example, and you care only about one, don't write target is equal event.target. Just put it in curly braces, one or more that you care about, and it'll extract from you. It'll extract for you the properties that you care. So the change event is sending the entire event object. But in the function on input event, we are doing destructuring, so we're just extracting just one property, which we want. So that was the view from the parent, right? Order processor is giving something to the child. So we are in the application component, which is a maybe root component, which has inside, you can see that. In the template, we are using order component. Just because of that, order component is a child of app component. So what's happening inside? When the stock is coming into that child, how do you get it? See that input, at input. You mark a property one or more with input. If you want, just put at input and name of the variable. If in this case I'm using setter. So whenever somebody will be giving me the value, Apple or Google, whatever stock symbol it is, this setter will be called and I can put any business logic that I want inside the setter. That's it. How do I send data from the component out? As I said, you're emitting events. So in this case, I defined one variable last price. Say I'm getting stock price quotes from somewhere, and I want to send them out. I want to create a component that will be displaying the latest stock quotes. So what I do is, in this case, I'm using set interval inside the constructor, just to emulate as if I'm getting data from stock exchange. I use set interval, and every second I am generating random quotes, just math random, right? And okay, I got the latest quote. I generated it or I got it from somewhere. How do I send it out? To my parent. So what I do is, up on top, output is an annotation that I used with a property last price, which makes it output property. That property should be of type event emitter. Moreover, TypeScript supports so-called generics, and in angle brackets I put in there so that I'm planning to emit objects of type iPrice quote. It's an interface. And down there, this dot last price emit, and I'm emitting an object that I just created in this component. They will receive standard event object, which with a payload, with my information about the stock price quote. Accordingly, parent is listening to this event. To which one? Look at this price quarter in the template, in the angle brackets. It listens to last price. It's my event. It's my custom event. I decided to call it. Whatever you call the output property is your name of the event. The parent listens to it and call something else. And how do I extract the things that I received in the parent? Look in there, in the price quote handler down there. I received the event. This is event handler. So I say that I'm going to get a payload of type iPrice quote, because this is what the child is sending over. and I extract the stock symbol and price and do whatever I need to. See, loose coupling. The child component didn't know how to get data from the outside world. It declared input property saying somebody will give it to me. And the other component doesn't know who to talk to give the data. You just say, I'm going to send you an event. Take it. So this is complete reusability and loose coupling. Projection, which used to be called transclusion. If you want to pass a piece of data, a piece of HTML to a child component, you just down there again. For some reason I structured the slides that you need to read them bottom up. So child component in the template of the child, just put in angle brackets and G content and slash and G content. And this is something that will be replaced with the content that will be projected from the parent. How to project? Not too difficult. Inside the parent component, now take a look. If your parent component has a child, in between the child tag and slash child, put any HTML you want. Whatever you put there will jump inside your child and replace ng content. That's it. Through that so-called insertion point. Let's talk about the project structure. Design is nice and clean, but your life will be a little more complicated in terms of setting up a new project. Why? First of all, you used to program in JavaScript, and JavaScript was running in the engine, in the browser. Not anymore. You are writing in language A, and the language B will be running. So let's, again, as usual, let's look at this structure of the directory from down up. You will have some configuration files in your project. You will need to configure TypeScript properties. TypeScript is a transpiler. What is a transpiler? It's a compiler, but it converts from one source language to the other source language. Not to machine code, not to the bytecode. From TypeScript source to JavaScript source. But JavaScript has different flavors, right? Do you want to transpile it in ECMAScript 3, or in ECMAScript 5, or in ECMAScript 6? It's a property of the compiler, right? What kind of module system do you use? Do you want to use CommonJS like in Node? Or you want to use standard ES6 system, or maybe AMD? You specify that as property. So you have tsconfig, configuration file. Since we are using modules, we need a module loader. Modules were defined in ECMAScript 6 spec, but the loader wasn't. Initially it was, and they removed it. Hopefully it will be back in ECMAScript 7. But there is a polyfill, which everybody is using now, called system.js. It creates a system object that eventually will be standard in all browsers. System object has maybe 4 or 5 functions in there, but we are using 2. System.config to say how you're going to load the modules. Are these modules CommonJS type or no? Where is your application? And system.import is actually the loading thing. I'll show you a bit later. You'll see the code. You have an HTML file, and in the script section you will say system.import and name of the main module. That's it. So the loader will load the main module and see, are there any imports in there? Oh, they are. Yeah, there are 5. There is homepage, footer, header, and so on. It'll go and load those. Those also have import statement. It'll load everything. It'll load the whole tree. So you are not adding any script text to your HTML page. You're just loading the root TypeScript file. Node modules is a folder where you download all required packages. The Angular itself is distributed as an NPM package. If you want to download something else, like in this auction application, we are using Bootstrap from Twitter. Bootstrap is built on jQuery. So I just do npm install jQuery, npm install Bootstrap, and it jumps right into that folder and Node modules. So all your development dependencies, or maybe runtime dependencies, are in Node modules. The application code, up on top you see the folder app. It's here, the root folder of your application, which has components typically and services. In components, you have a folder for every component. You need home component, you write a folder. In there, you're going to get HTML file, TS file, which is TypeScript, and you're going to get what? You may have CSS if you want. You may have 3 separate files, you may have just 1, but every component is sitting nicely in its own subdirectory. So as I said, system.js, in your main TS file, you invoke the function bootstrap. You're saying load. Bootstrap for me is the main component, the root component. And it'll go and load this main.js. In main TS, sorry. In main TS, I have this reference to application component. It'll go and find, oh, application component is in the folder application. So it'll load it. It'll load application component. It'll see, oh, application components need something else. Import home, import carousel, import footer, import navbar. It'll load them. So that's how the whole machine works. The toolbox it's your toolbox. There are so many different ways and not many different blocks, and we went through all that, and this is what we finally decided. Because you can go crazy when you see all these toolings that you need to learn. What works for us? So our sample tool set. You write the application TypeScript. It consists of modules, as I said, with export imports, and modules will be loaded with system.js. There's no choice, pretty much. System.js is the loader. Even if you will decide not to work with TypeScript, you will still be using that, loading ECMAScript 6. If you want to do quality check, TS-lint exists. Then TypeScript need to compile it or transpile it to JavaScript. There are 2 ways. Either run it on the command line, but if you are using in the development mode, if you will be using system loader not only loads the TypeScript files, but it also transpiles them on the fly. So you keep writing TypeScript. You run your application. It generates source maps for you. So in the browser, in Google, open up developers tools. It runs JavaScript. Source map shows you TypeScript. Put breakpoints and debug TypeScript. Nice and clean. So for testing, Angular has its own module, Angular testing, which for now works with Jasmine, but they've created API over there, like describe it. These things already works. Now, you want to prepare for deployment. How do you deploy? First of all, you bundle things. Your application will have 100 files or 200 files or 50 files. You don't want to deploy all of them, right? So you create bundles. So we are using Webpack as a bundler. So we wrote a simple script. I should have time to show you a slide. And in that script, you do what? You defined the loaders. I want to load CSS and I want to convert them. I want to load TypeScript, I want to convert them. I want to minimize using Angular.js. I want to use general piece, reusable common piece, which is Angular. So you'll create a bundle for your code, and you as a bundle.js, for example, one file. And you, as a second file, will be created, maybe vendor.bundle.js. So finally, if you have 100 files, you can have 2 files. I'm not talking about images. You may have images, of course, large ones. Small ones you can inline as well. So you will be deploying 2 files. One code is yours, and one is all these frameworks that you put in there. So small application like this auction, it's under 200K. Deployed and gzipped with Angular included. Everything. TypeScript, really quick, I don't have much time. TypeScript is a superset of JavaScript. It makes you much more productive. All IDE supports it. Visual Studio, WebStorm. You can use Sublime Text if you want. They have so-called static type analyzers. You type, it immediately shows you errors. Immediately. It understands types and everything. If you want, you can go to TypeScriptLang.org. That's the site for TypeScript. And they have playground. You can interactively try different pieces. And these are a couple of snapshots from there. On the left-hand side, I write class bar empty. It immediately transpiles it to you in JavaScript. The best part of TypeScript is that it transpiles it into a JavaScript that people can read, which is unusual. Because we used to work with Dart before, another Google's product. It's not readable. code in JavaScript. But in here, look at this, Clint. Do you understand the JavaScript? Yes. It's generated for you. Classes. On the left-hand side, you have TypeScript class. On the right-hand side, you have an equivalent function in ECMAScript 5 flavor. Class with constructor, I already told you. Public will immediately eliminate the need, like on the right-hand side, lines 3 to 6. You don't need to do this in TypeScript as long as you write them public or private. Inheritance. As I said, during the runtime, you still have JavaScript for example inheritance, but on the development side, you see class A extends B. Simple. Generics. It's similar to Java. It's similar to C#. If you don't want to allow during the development type to put into, in this case, into array anything but person objects, or objects that's of type person, then you put it in angle brackets. On line 17, I'm trying to put there an animal, instance of an animal. Immediately I see this red squiggly line. You said that you're going to be placing persons in there. Can do this. But TypeScript doesn't stop you from doing this. If you think that animals maybe are better than people, keep it. It generated for you the code on the right anyway, right? Remember, TypeScript helps you during the development, but you can say I don't care, and you will still get your JavaScript code. Lambda expression, fat arrow functions. It's in ECMAScript 6, which is supported by from 60 to 90% of the browsers. Actually, all the way around. Browser supports anywhere from 60 to 90% of the language already. So instead of writing anonymous function, parens, and something in curly braces, then you write this. Parens, maybe arguments in there, fat arrow, and then the body. In this case, one liner, but you can put in curly braces multiple lines. Interfaces. Interfaces don't exist in JavaScript. So, but you can use them to protect against your own mistakes. So you define an interface IPerson saying these are the properties that I allow, and then you declare variables of this type in your other code. If you make a mistake, TypeScript will tell you you made a mistake. But since there is no interfaces in JavaScript, they will be evaporated. During the compilation, on the right-hand side, you don't see any mentioning. Why? Because there is no such thing there. So it's only for you during development time. A class can implement interface accordingly. TypeScript compiler, how do you get it? npm install, and it's in -G, it's on your computer globally. Otherwise, it'll be placed inside the node modules. How do you start a project? I'm going fast because I don't have enough time. I can talk for 2 hours. How do you start a new project? npm. npm is your whole thing. From now on, without npm, you don't even move. You don't leave house without npm. npm init -y. -y, create me a default package JSON and don't ask me any questions. Then you open up package JSON and you add several lines for Angular in there. And then you run npm install. npm install command reads what do you have in the package JSON. Oh, I need Angular, I need jQuery, I need this. It'll install everything in the subdirectory node modules. What else do you need? You need some server to feed your application while you are running. There are different ones, simple ones, HTTP server, live server that we are using all the time. npm install live server done. You want to try something out? Live server in the terminal window, in the command prompt window from the root of your project. And it'll start the server and it'll feed your index.html. Package JSON looks like this. In the middle, dependency section, everything that I need for Angular. Now Angular is in beta 9 and probably within a month pre-release will be out. They already announced it. Hello world, finally. Usually people start with hello world. I'm pretty much ending. So hello world, that's the code. And in this case, you see I have a name inside the constructor, which is using binding, will be placed inside the template displayed on the screen. System.js, as I said, it'll load this file. It's main.ts. That hello world was in the file main.ts. Now take a look at the index.html. We already installed Angular using npm install, right? So all Angular related files are sitting in the folder node modules. So the red portion on top is where we are getting Angular. In the middle, script section. This is what I need to do to say to System.js how to load my application. So I'm saying import main.js and a couple of options. Transpiler, see, by the way, I'm saying please transpile this code for me using TypeScript transpiler. There are other transpilers like Babel or Tresor. We are using TypeScript. So the code is loaded, my hello world, and transpiled on the fly. Now let's talk about reactive programming a little bit. Reactive extensions are embedded. RxJS from Microsoft is embedded right inside Angular, so you got it already. You install it, you just need to put in one import statement in the index.html. In reactive programming, everything is a stream. So basically, you click on the button. It's not just a click as we used to know before. It's a stream. Yes, it consists of one click. But what if you click again? You're getting a next element of the screen. What if you are dragging a mouse on the screen? Maybe you need every coordinate. They can be pushed to you using reactive extension observable stream. What if you are making UI? No, sorry. What if you're making HTTP call? What do you get back? Not a promise anymore. You're getting observable. If you are an old-fashioned guy and you want to still work with promises, fine, convert it. But by default, you're getting observable. You're getting data from the WebSocket. Subscribe to them, you're getting observables everywhere. So you can't hide from it anymore. So observable object is a producer. It sends you the data one element at a time. 1, 2, 3. What observable can do? Only 3 things. It can stream elements. It will give you a next element. It can throw an error. And it can indicate that the stream is over. But what is very super duper important, that streaming doesn't start until somebody subscribes to it. If nobody cares about your data, it will not be pushed. The code will not even be executed, right? So the fact that you declared it doesn't start until you say subscribe. Then the data is pushed on you. It's a push model. All right, if we have an observable, there should be an observer. Somebody who cares about the data and somebody who knows what to do with the data, right? So you need to define an observer. What observer should be able to do? The same 3 things. To know what to do with the next element if it's given to observer, to know how to process an error, and to know what to do if the stream is over. Pretty simple. The main power of all these observable streams is laying in the operators. As the data is pushed to the subscriber, you can put them in a chain of operators through the chain. In this case, emitter sending nice, rectangles. And you put them through the map operator, even though it has parentheses, and it turns them into triangles. Then you put them through the filter. You used to have 3. I don't need 3 anymore. You have only 2. So you chain, and very nice and clean code. An observer will get only what you want him to see. Let's take a look at the example of observable events. Observable events. First of all, in Angular, we have obviously form API and some controls already emit observables. In this case, input field, you say, this is an Angular control. See this and gform control. I want to bind it to a property of a class. This I declare search input inside the class of type control. In constructor, I create a new control. And as I type in this input field, this search input control has a special property, value changes, that emits already for you. Important, when it's going to emit? Only if somebody will subscribe. It won't emit for nothing. So you keep typing in the input field, and you can subscribe to all these characters as events. You want to create a search which immediately reacts. Maybe you want to get quotes from the stock market. You type, and observable gets the data. And in the middle somewhere, you can see value changes, debounce time, and subscribe. I could have written subscribe without debounce time, but I wanted to show you an example how you would change the operator between the emission of the elements and subscription. So I'm saying debounce time means delay, wait for 500 milliseconds. They are typing, they want to place an order, but let's give them 500 milliseconds. And only after we do subscribe, we change. If somebody knows Java, Java has streams and there are similar stream operators. You change them. But in Java, it's almost nothing comparing to what they have in RxJS. In RxJS, they have probably 100 operators, different ones. So in this case, we subscribe. You write a function subscribe. What do you need to give to the subscriber? You need to give something that knows how to do what? 3 things. You need to provide observer. You need to give a function that knows what to do if the data arrives, what to do if the error comes, and what to do if the end of stream comes. So in this case, I provide only one using fat arrow. Stock, it's like an anonymous function. Stock, I assume that somebody will give me, I receive whatever the user typed in that input field, right? Maybe I'm getting stock quotes. Stock, so what I want to do, the body of the function, this dot get stock quote from server, maybe I received it from somewhere, and by default, implicitly it returns me the result. So in that case, I am assigning it to the this dot, to where? I'm calling this, I don't assign it anywhere actually. I call it this get stock from quote service and I put it in the console. But I could have assigned it, of course, to a property of the class and show it on the screen. Let's bring HTTP to the mix. Again, the same thing. When you do HTTP get, by the way, class, through the constructor, it injects for you HTTP objects just by declaring the argument of this type. Then you say this HTTP that you received through the constructor dot get. You're getting program from that URL. So what do I do in this? HTTP by default returns observable. What you can do with observable, you can put it through a chain of operators. In this case, I say, I want to do a map first. I want to convert it to JSON. And then I do subscribe. If I would comment out the line subscribe, there would be no HTTP request made at all. The fact that you see and you look, you see HTTP get. Don't trust your eyes. It's dead until there is a subscriber. Nothing happens. Now we have a subscriber. What do I give a subscriber? An observer. What observer should know how to do? 3 things. What to do with the data, errors, and end of stream. Change detection. No digest, no apply, nothing. There is a special Zone.js module, which was defined in TS39 committee. First, it was implemented by Dart, by the way, and now it's implemented by Angular team also, and it watches what is changing. I don't have much time, so I will be finishing quickly. But the point is, the change detection, there's no cycle at all. It goes from top to bottom to the children of the component. It checks all the children unless you will say, this particular component only needs to be checked if the input value, the binding to the input property changes. Otherwise, you can mark it no. You can say to a component, I want to use change detection strategy on push. If you said that, Angular will not even check it unless you change something through the input parameters. As I say, component lifecycle has a bunch of hooks which you can use. You can write code in any of these functions to intercept different important events. Deployment. As I said, you have a bunch of classes, but you will be deploying a couple of bundles. We use Webpack, and as an output, we have gzipped bundle code for my code, and the other code for reusable third party, in this case, Angular. And I have an index. That's a deployment, a sample deployment. Of course, you will have, if you have large images, you will have more files, but other than that, this is what you deploy. This is how Webpack config looks like. Again, I don't have much time to explain you all that, but you put it in a set, through the set of loaders, like CSS loader, HTML loader, and you download all of them as packages to NPM through NPM. Actually, the pack comes with a bunch of loaders. They are converters. A loader converts one file at a time. Plugins can process a bunch of files. In this case, I'm using a bunch of plugins. The last one is Uglified.js plugin, which minimizes the data. There's a bug, so you see that to-do thing. Which task runner do you use? Of course, there are all these grunts and gauls, all these other fancy things. We don't have time for that. For writing hundreds and hundreds of lines of configuration. This is NPM scripts. So this is what I need to do. Actually, first half of the slide, not all, is the configuration, sample configuration, which includes development configuration and production configuration. A couple of commands that can start the server and serve you as a developer, or start the whole process, build a bundle, and deploy it to the server. And that's about it. These are the links. The book that we are finishing, actually, Manning already sells the mean version e-book. And if you want to get a discount, there's a discount like 39% off. They already sell like 300 pages of this book. I'll be running a workshop in New York for 2 days up on top. There's a discount also. There's a bunch of examples for the book in that GitHub repository. If you want to play with these examples, regardless if you will buy the book or you won't buy the book, the code samples are there. That's pretty much it. Thank you very much.